Hey guys, what I'd like to do today is I want to talk a little bit about the math. Um, we started this worksheet, Newton's second law, practice problems in class, and I had a lot of people come to me and say that they were completely and utterly lost and they have no idea where to start. So I'm going to start from the very beginning, from the very beginnings of math. Throughout your life, you've been given problems like 1 plus 2 equals 3. Right? We've all seen that math problem. And or it's usually listed something like this. It will say 1 plus 2 equals blank, right? And so you've got to decide what goes in that blank. And the equal sign is something of a finish line. It's like if I just do whatever's needed over here, I'm going to get the answer that belongs on this line over here. So I just add up 1 and 2 and I get 3. But I'm going to ask you to look at this a little differently. I want you to look at the equal sign as not a finish line, but just like a comparison, almost like a scale, like a seesaw. And so the equal sign is just saying that everything on this side is the same as everything on that side. And if you look at it like that, it becomes a lot more useful because I could say something like 1 plus 2 equals 3, and that's true. I could just as easily say 5 plus 1 plus 2 equals 3 plus 5. That's going to be the same thing. That's 5, 6, 7, 8 equals 5 plus 3 is 8. So the equal sign isn't the end point. The equal sign is just a tool on my way to discovering something. And so if you haven't taken algebra before, algebra kind of explores math using the equal sign more as a tool than as a finish line. And so what we try to do is we try to solve for certain variables. Now, a variable is just when we take one of these numbers and we say the same thing. We say 1 plus 2 equals 3 or equals what number, right? And so instead of saying what number, we just say x or any letter or symbol that we choose. So 1 plus 2 equals x. Well, now I can solve for x and say 1 plus 2 are like terms, so I can add them up. I can simplify that to 3 equals x. And sometimes it might be written another way. It might say 5 plus what number plus 2 equals 3 plus 5. All right, I've just taken this one up here and I removed this 1, right? And I just replace it with a blank or with an x. 5 plus what number plus 2 equals 3 plus 5. This is a little bit more complicated. But I always start it the same way. I combine like terms and I try to get the variable alone so that it ends up looking like this, where it has the variable on one side is equal to something. So over here I have like terms, right? 5 plus 2, I can do that. 5 plus 2 is 7 plus x equals 3 plus 5. That's 8. Well, I'm still not quite, the x isn't alone yet. My goal is to get the x alone so I can find out what the x is equal to. So if I'm adding 7, I can undo that. 7 plus x. Well, I want to subtract 7 from both sides because I know that 7 minus 7 is going to be 0, and that'll get my x alone. So I subtract 7 from both sides, and I end up with 7 minus 7 cancels out, and I have x equals 8 minus 7 leaves me with 1. X is going to be equal to 1. Now, hopefully you've done this before, but essentially the rules are like this. 1, always combine like terms. That means if I have x plus x, that's going to be the same as 2x. I want to combine them because they're similar things. I want to combine them. Or if I have like 3 plus 9 plus 103, those are all like terms. I can add all those up, and that's going to be 106, 115. All right, I can add those up because they're like terms. Now I might have 7 plus 4 plus x. Well, now 7 plus 4 is 11. Those are like terms, but I can't really add the x to 11 because those aren't like terms. So you always want to combine whatever like terms you have. Then, 2, whatever you do to one side, what you do to one side of the equal sign you must do to the other. So if I'm going to add 7 to one side, I have to add 7 to the other side. If I'm going to divide by 4, I have to divide by 4 on the other side. Because if I go back to my balance here and I look at my seesaw as a balance, right? I know 1 plus 2 equals 3, but if I add 4 to one side, well, now this side equals 4, 5, 6, 7, and this side only equals 3. So it's no longer in balance. This side's heavier now, and it's going to tip my scale. So whatever I do to one side, I have to do to the other. And to be honest with you, it doesn't even matter what I do, even if it's not helping me solve the problem, right? Adding 4 to this doesn't help me solve the problem, but it's still true because I did it to both sides. So combine your like terms. What you do to one side of the equal sign, you must do to the other side. And 3, you're always trying to get the variable alone. Follow those 3 rules and you're going to solve these problems, no problem whatsoever. So let me go to our harder formulas now. This isn't 1 plus 2 equals 3, right? This is high school, right? So I've got a formula now for physics that's called F equals ma. Now, I told you a long time ago, we don't do multiplication with x signs anymore. That's terrible. They never should have taught you that in the first place because it's going to get confused with the variable x. So for multiplying, we don't do x's anymore, okay? You can do an asterisk. You can do 2 variables right next to each other. That means multiplication. You could do a number in parentheses and a number outside of the parentheses. That means to multiply them. You could do a dot. So you could say x times y, but no more x's. All right? Imagine that you just want to say x times y, right? X times y. Well, that's actually saying x times y because 2 variables right next to each other is multiplication. So no more of this. We can't do that. All right? These are your options up here. So F equals ma says that the force acting on an object equals the mass of that object times the acceleration of that object. And all of these problems in this worksheet are going to give me 2 of those 3 variables, and then I solve for the remaining one. So how much force is required to accelerate a 2 kilogram mass at 3 meters per second? Well, 2 kilograms is a measurement of mass, okay? 2 kilograms measures mass. And meters per second squared is a measurement of acceleration. And we talked a lot about units so far this year. I know those are true because I know that kilograms is a measurement of mass, and I know that meters per second squared is acceleration. Plus, on top of that, the question actually says how much force is required. So that means that I'm going to start this problem like this. And this is the way I want you to start every one of these problems. Figure out what you know already. Then put in my formula. F equals ma times A. You will make far less mistakes if you write your formula down first. It's just a fact. I've been doing this long enough to know students mess up all the time when they don't write the formula down first. Then I'm going to substitute in the values that I know, right? I didn't leave much space on this worksheet. I'm sorry. So F equals MA. I can substitute in this M, right? This M is my mass, 2 kilograms. So F equals 2 kilograms. And A is my acceleration, 3 meters per second squared. 2 kilograms times 3 meters per second squared. 2 times 3 is going to be 6. So F equals 6. And I could write it 2 ways. Now, 2 times 3 is easy, right? But kilograms times meters per second squared, that's not any kind of math I can do. 2 and 3 are like terms. I can combine them. 2 times 3 is 6. But kilograms and meters per second squared are so different, I can't multiply them together, so I carry those units over. Kilogram meters per second squared. Now, if you remember from the slideshow we just went over, I can replace that with just newtons, a capital N. We measure forces in something called newtons because that is way easier to remember than that. So the force in this problem was 6 newtons. Let me move on to the next one, and we'll do that one together too here. It says, what is the mass of an object that requires 100 newtons of force in order to accelerate it at 10 meters per second squared? Step 1 is figure out what I know and what I want to know. What is the mass? I'm going to be solving for mass in this problem. Of an object that requires 100 newtons of force. Well, that's my force. And in order to accelerate it at 10 meters per second squared. That's my acceleration. This is my force. So let's start with my formula. F equals M times A. Now, this time I'm looking for M. I don't have an M value yet, but I do know my force is 100 newtons. Sometimes it's easier if you write it below it instead of side by side because it lets you kind of see where things drop down. M, I'm going to keep just M. Acceleration, I'm going to fill in 10 meters per second squared. Now I want to know what the mass of this object is. I've applied 100 Newton force and it accelerated 10 meters per second squared. So now what is the mass of that object? Well, m times 10, I want to get the m alone. So just like we subtracted when it was added, I want to undo multiplication. And I undo multiplication by dividing. So I'm going to take this side and divide it by 10 meters per second squared. And I'm going to divide this side by 10 meters per second squared. Now, 10 divided by 10 is 1, and I can cancel those out because m times 1 is still m. So those are erased. They canceled out. I'm left with just m over here. And I have 100 newtons divided by 10 meters per second squared. 100 divided by 10. If I put that in a calculator, I'm going to get 10. 10 kilograms equals my mass. Now, you can ask me where I got the kilograms from. Since I know it's mass, I know it's going to be measured in kilograms. But if we go back up here and look at these units up here, right? I had kilogram meters per second squared. That's the units of a newton. This 100 newtons is actually these units. And then I'm dividing that by meters per second squared. That's this unit divided by this unit. They cancel each other out, and I'm just left with kilograms. Now, Oh, sorry. There we go. So you don't need to necessarily know that, because I know mass is going to be measured in kilograms. I know acceleration is going to be measured in meters per second squared. And I know that my forces are going to be measured in newtons. So if I'm solving for mass, it's going to be in kilograms. That's enough. You don't have to know all this, but for some people it's helpful. So the next one, what is the acceleration of a 10 kilogram mass pushed by a 5 Newton force? I start with the same thing. I'm looking for my acceleration. I don't know what that is. 10 kilograms, that's my mass. 5 newtons, that's my force. I put down my formula. F equals ma. I fill in what I already know. I know I'm looking for A. I know my force is 5 newtons. 5 newtons, right? That's my force, equals my mass, 10 kilograms, times my acceleration. 5 newtons equals 10 times what number? Well, I need to get the A alone, and the A is right now multiplied by 10. Undo that multiplication with division, 10 kilograms. Divide this side by 10 kilograms. And I end up with 5 divided by 10, or 1/2, equals my acceleration. And now again, the units, the newtons divided by kilograms, are just going to end up meters per second squared. And I can go through all this again to show you why, or I just know that acceleration is meters per second squared. So that's the first 3 problems. Now, I intend to go over these more in class tomorrow, but I just want to make sure you understand how to do the problems. You start by looking for what I know. What am I looking for? You know, what is the answer going to be? Mass, acceleration, velocity, what's it going to be? And what values do I know already? Write the formula. I can't overstate this. Write the formula. In this case, F equals ma, but there's many more formulas you're going to run into in physics. And then finally, get the variable alone. Okay, and you do that by reversing the work done around it. If it's addition, you're going to subtract the same amount. If you have subtraction, you're going to add that amount. If it's multiplied, you divide by it. If it's division, you multiply. You do the opposite of whatever the function is, whatever the math is. You do the opposite of it. And those are your 3 steps. If you do those 3 steps, you'll be able to solve these math problems. Now, again, we're going to go over it in class again later, but I wanted to give you a point where you can come back to and you can try these other exercises out, and then we'll give you other problems to solve too, okay? Because there's only 7 on this page. Anyway, it's late. I'm going to bed. Have a good night.